So now we're going to discuss simple combined events and tree diagrams. How to draw the tree diagrams of the simple combined events. Let's see. We are going to draw tree diagrams for the example we are going to do. For the simple combined events, there will be two examples in this video you're gonna see. Let's take two coins first. Head is above, then there will be tail, of course, below, and the second coin as well. There is head here and tail below. So let's see how can we understand this type of situation or this type of example. By supposing something. There is no question given, so we have to suppose something. That what we have to find, let's suppose we have to find the probability of B, or it can be probability of A. I'm taking B. So B, what is B? If we have to take the find out the probability of an event B, let's say that B is the, okay, yes, B represents an event in which we get, let's suppose, same outcomes. Same outcomes. So now we have to find the probability of B. So for finding the probability of B, we have done it before. In the first video we have seen that probability of B means number of favorable outcomes divided by total number of outcomes. This is the formula. So for favorable outcomes, we have to draw the T diagram. We have to see what is the sample space. Total number of outcomes is actually the sample space, and total number of favorable outcomes is the same type of outcomes. We're gonna see that. What does it mean? First coin, second coin we have written, and what is the outcome of that? What can be the possible outcome of that? If first coin is head, the second coin and the first coin can be head, or first coin can be tail. Second coin in this case will be head or tail. We have done this type of situation. We have seen this type of situation before. Or it can be for the tail as well. It can be head or tail. So the outcomes which can come are H and H, H and T, T and H, and T and T. Let's write them. These are the outcomes which are coming. So this will gonna make the sample space. This is another way to write it down. This is it. So this is the sample space. Head head, head tail, tail head, tail tail. So this is our total sample space. So what are the number of values in the sample space? 4. Because we, in the formula of probability of B, we have to write the number of favorable outcomes divided by total number of outcomes. That's why I'm writing the number of sample space. These are the 4 options which can come in the sample space. What is the number of favorable outcomes? Favorable outcomes for B. B represents an event in which we get same outcome. How many times we get same outcomes? 2 times, head head and tail tail. So number of favorable outcomes, or number of outcomes in B, will be 2. So NB divided by NS, this is the formula. Number of favorable outcomes divided by total number of outcomes in the sample space. So this is how we will gonna write it. It will gonna give you 2 divided by 4. Yeah, this is it. So 1 by 2, 0.5. So what is the probability of B in this case? That is 0.5. And total probability of can be 1. The maximum probability of any event can be 1. So it is between 0 and 1, and minimum probability can be 0. This is an important point. If we are taking C as an event that both the values or both the results are not same. So for not same, what will be the probability of C? Let's see. It can be taken out using 2 methods. One is 1 minus 0.5, because 1 is the total probability, and if we subtract the same one from the total 0.5 from the total probability, if we subtract the same one we have found, so we're gonna get the probability of the different one. So this is one way to find out the probability of C. because the outcome can be same or different. So these are the two situations which can occur. So if we're gonna subtract the same from 1, we're gonna get the probability of different events. Okay, now we're taking another example. We're gonna take these two uh, wheels, we can say, on which numbers are written. Spinning wheel A and spinning wheel B. No, this is taking a lot of space. We need 4 options, 4 lines. We're gonna redraw it. For A we are drawing, there are 4 possibilities for A, spinning wheel A, and there are 4 possibilities for spinning wheel B. So in A, when we are spinning the wheel, the arrow can come on any of these 4 values. Spinner A, and let's write here spinner B. Okay, so arrow can come on any of these these 4 values. So we're gonna write all those values over here, 1 2 3 4. This is how we're gonna do it. For the first one, for 1, if 1 is there, then the second wheel can give you either of these 4 values. Again, if 2 is there in the first wheel, the second wheel can give you either of these 4 values. And in the same way, we're gonna find for 3 and 4. We're gonna write all these possibilities, and then whatever they're asking, we can find it out. First of all, we have to make the sample space, and then what we have to see that which probability they are asking. If they are asking for the probability for the same events, we're going to pick up the same events and we're going to write its number divided by total number of values in the sample space. So this is how we're going to do it. So I think this is clear to you. Now you can attempt the basic questions in 3A. Please attempt the basic level and intermediate level of 3A. So then we're going to come to the combined events. Thank you.